Are you wondering how you can organize multiple agile teams in a way so that they can collaborate efficiently and effectively while working on the same product? The first thing you need to realize is that this challenge is not simple. Many organizations have been struggling for many years in order to find a solution that works for them. So it's not trivial, because otherwise there should be a simple, obvious solution that all the organizations are adopting. But even if we are using something like an agile scaling framework, there's a steep learning curve, and usually organizations make a number of mistakes. And the first mistake they typically make is that they assume that we need a large amount of people because we've been using a large amount of people in the past. This is often not true, because when we have a lot of handovers across team boundaries, we need a lot of coordination, and the efficiency of teams is pretty low. When we have a lot of people and many teams, we need a lot of coordination, and this coordination reduces the effectiveness of teams. So what we are trying to achieve with this approach called scaling agile is not to scale up agile. What we are trying to do is reducing the management and coordination effort required to enable teams to deliver value in software development. What I see in practice is many organizations, they just dump their teams together using the Scaled Agile framework and do something called a PI planning, which is where the high-level blocks that the teams are delivering to the customer are planned on a 6 to 12 weeks time period, and see how those teams would collaborate in order to deliver this value. So what I sometimes see is, when I get into an organization, is a plan that looks just like this one here. If it's not obvious that this plan has a problem, just look at the color scheme. You have a few blue cards, which are features, which is value delivered to the customer. You have a whole lot of red cards, and red cards are dependencies. That means each red card is a coordination that needs to be done across team boundaries in doing the work. A huge amount of incoming dependencies typically means that this team receives input from many teams, so they do depend on other teams in order to get their work done, which typically means as soon as a few things are missing, they are blocked. They might be the best developers in your organization, but they are waiting for other people to do their part before they can create any value to the customer. Likewise, when we have a lot of outgoing dependencies, it means that other teams are waiting for this team in order to get their work done. So this team might be a bottleneck in the process because everybody is waiting for them. If anything happens in this team that delays them or blocks them from delivering their part to others, then everybody is blocked. Both of these are unfavorable conditions, and that is why I typically say that looking at a PI plan that appears similar to this one tells us immediately that we have the wrong team setup. We should look at a different team setup that allows us to deliver value with less coordination and with less risk of some dependencies not working out. There are some coordination issues that are inherent to the way that you set up your teams. The first one is when you have specialist teams. Let's just take analysis, development, and testing as one example of a specialist team. So developers are the ones that are creating the value, building the features that can be delivered to the customers. Unfortunately, in this model, they cannot do it alone. Only once analysis is finished, they get handed over the feature for implementation. That is a pattern that we see very often with a strong definition of ready. In some cases, a definition of ready is defined so strongly that the product owner and the team members cannot meet it by themselves, So we institute other functions in the organization, such as business analysis or even technical design, in order to make sure that teams have everything that they need to do their work. The good news is that as soon as anything gets into development, developers can work very efficiently. The bad news is that this efficiency is an illusion, because developers are only more efficient because the inefficiency has been outsourced to another team. And this outsourcing also comes at the price of time. So what we see is a team that is not experimenting, trying to find the best way to get something delivered. They may not interact with the customers, but they are waiting for this interaction to happen, and this interaction blocks them from delivering value. One thing that you should note in this model is that we have two major handovers, the first one being from analysis into development, the second from development into testing. Those of you familiar with waterfall organizational design will immediately realize that even if we would call this an agile setup, it's actually just waterfall in disguise. And that becomes very clear when we look at the cycle time. In this model, if we have first one sprint for analysis, then another sprint for development, another sprint for testing, and finally in the next sprint after that, we see the software being deployed and delivered to the customer. Then we see a cycle time of a minimum of 8 weeks, which is nearly 2 months. So this model cannot perform better than waterfall could, and it most definitely doesn't meet the promise of Scrum, that is working software in 30 days or less. Now let's take a look at a slightly better setup, and that is the component team setup. Of course, this one is just a simplified structure, and if you look at this in practice, depending on how the work is organized and how the components are sliced, we might get into the dependency hell that we mentioned initially. For a simple overview though, let's just focus again on what does this look like. You have the same kind of dependency chains that you might have in specialist team, except they are not specialized in IT functions, but in software components. The issue with component teams tends to be that we have interfaces across systems, and we should have interfaces, otherwise we're just delegating the problem to the user. So one system designs their components, creates the interface that is required to hand over data to the next system, and then depending on that, team members working on the next component would get busy doing their part. And all of this happens until the feature is fully implemented and can be deployed on the live servers. Depending on what features look like and how your value stream is organized, it could mean that we do not only have a lot of interface handovers, but that we have a lot of flowback during the implementation. And I have seen teams working in this way who were completely unable to deliver anything within less than 3 months. So we're not gaining anything when we're looking at this in terms of cycle time and time to value for our customer. There are, however, design practices that do enable component teams to be much more efficient with their time. And the first one is doing an API first approach. So first align on what your API would look like, and then based on your API specification you do the implementation. This is also typically what we do with design by contract. That works pretty well if we are in the known domain and we know what the features would look like. But as soon as we have exploratory elements in there and we are not certain of what the perfect solution is, our API can change at any time, and each time it does, we end up with cross-team coordination that might entirely kill the plan. As I hinted in another video, one of the better approaches is to design feature teams or generalist teams, that is, teams who are autonomously able to deliver the value to the customer. With feature teams, you would end up with a plan that looks similar to this one here. The first thing that you might realize in this plan is that there are no strings crossing team boundaries, and that is the very definition of a feature team. What you have is teams independently delivering value without depending on anyone to deliver something to them, or anyone depending on them to get something delivered from them. In this case, you might have milestones which aggregate the work of multiple teams into a business relevant outcome, such as a major release. But nothing that the teams do depend on the work of other teams. The only dependency we have in this kind of model is that we might have multiple teams contributing to the same release, and that is very obvious because we are working on the same product. This last image is the design of an Agile release train that came to be after I finished working with them. What you see here is no strings at all, and that is because we have bite-sized features which can independently be delivered by a single team. And the one notable thing that we have in this plan is a single red card, which in this case is not a cross-team dependency. It is a risk, and that risk in this case was due to uncertainty because we did not know what our customers really want. So what you see when you do scaling right, you absolutely can minimize the need for cross-team dependency. The most important question becomes who does what and when can we get the results. It is no longer the question of what do I need from you and when can you deliver it and how certain are you that you can deliver it. Those coordination meetings are exactly the reason why agility at scale is such a huge pain in many organizations. If you take a look at this plan, what we have are autonomous teams that basically do not require much scaled coordination except aligning on what it is that we are going to do and what I am doing, what you are doing, so that we don't do duplicate work. It is no longer about putting Lego pieces together and make sure that we end up with something that looks like a consistent building.